今天下午人不多啊，并且我没想到我们这个会场挺简陋的，但是我们今天的话题是很高端的，所以在座的各位来听的，证明你们的思维是非常高端的。即便这个厅坐满了，我不觉得所有人能听得懂，所以在座的各位啊，恭喜你们！哈哈哈。OK， 我看到有老外在这儿，所以我们还是 prefer 英文来讲。OK， 如果有问题的，我们可以接下来用中文交流，好吗 ？OK，Hi， Good afternoon. You don't need translation. We will use English. Okay. Thanks for joining this session. We are from eBay. My name is Xiaogang. I'm a cloud engineering manager, and this is my colleague Tommy.
Thank you. My name is Tommy. I'm the senior manager of the site operation in eBay. I'm running like the platform reliability team in eBay, and we managing that the hundreds and thousands server in eBay to serve like the thousands application in eBay for the global platform. So Xiaogang is major for like the developing the Kubernetes in eBay. That yes. We running the data center fleet to serve the traffic. So our purpose is kind of be keep the large scale the data center to serve the traffic and keep that reliable and scalable. Okay.
Yep. So it's very happy to join the first Kubernetes conference in China, right? The first one.
Yeah, that definitely. Like the Kubernetes is more and more get popular in the like the globally, especially in China.
Yep. And also, I think the community of China. This means the community of China get increasing influence in the world. That's why we have Kubernetes conference in China, right?
Yeah.
So we will share today the magic experience with Kubernetes.
Yes. Also, that we will showing about how we design the Kubernetes for eBay, and later I will share some like experience from the like the operations perspective that how the Kubernetes magic help us to manage those kind of large scale the data center in eBay. Okay. Let me in like the warm come the like the Xiaogang to give us the presentation. I will come back later.
Yep.
Thank you.
Thank you. Thank you, Tommy. So this is our agenda for today. So first, I will talk a little bit about eBay, the business, and then our fleet, and how Kubernetes manage our fleet in Magic. Kubernetes concept of a model and a controller is the most impressive for us, so that we just think to use Kubernetes model our data center. By these models, Tommy will show you how easy it is to operate a data center and cluster in large scale. Okay? At the end, we will try to use 5 minutes for Q&A, but I'm not sure whether it is enough. We can have a further discussion through other channels. Okay, this is about eBay. eBay is an internet e-commerce company founded at 1995 in California. Till Q3 this year, we have 177 million active buyers all over the world, 22.7 billion US dollar GMV with 1.1 billion live listings. You might know the famous auction business model on eBay at the very beginning, but actually right now, 89% of the business comes from fixed price trade. eBay is a global company. 59% of the business comes from international. To support such a large-scale business, we need a strong infrastructure. We have 3 data centers in US. We have 15 pop data centers all over the world, including Australia, Europe, and Asia. We have 200,000 managed VMs and 100,000 VMs to host 4,000 applications and services. It's a large scale. I want to say, to manage such an infrastructure in large scale is not easy. I think maybe most of you in this room has similar experience like this, right? We in eBay are the same. But as an infrastructure team, if you ask me what is the top one principle to run your infrastructure, this is my answer. Infrastructure should play magic. How? This is my session, right? My presentation. It's a long way for us to manage a massive infrastructure. At the very beginning, eBay, almost all the applications in eBay were running on bare metals. Start from 2010, we built our first cloud platform based on VMware virtualization technology. But 2 years later, OpenStack is the hottest open source cloud platform in the world. And then we built our second generation cloud platform on top of OpenStack. But until 2015, we found that our business is running on 3 different cloud platforms with 3 different technologies. It's really hard for us to manage our infrastructure and to ensure the availability and the reliability. Then we start to think that it's time for us to have a unified platform to manage all the fleet in eBay. We start Kubernetes at that time. Our vision is to use Kubernetes as a unified fleet management platform, which can provide high available, high efficient infrastructure service. Remember what I said minutes ago, right? Infrastructure should play magic. But how? I think you have the answer. That is Kubernetes. That's why all of you are here, and we are here. With 3 years effort, we run almost all the workloads in eBay on Kubernetes. We run our search engine on Kubernetes, which is the CPU and memory intensive application. We run Hadoop on Kubernetes, which use CPU and disk heavily. We have a database running on Kubernetes, which is a good example for stateful application, which need high I/O throughput. And we have our POP clusters, which responsible for traffic ingress and balancing running on Kubernetes. Front end is easy because it's stateless for sure, and we are building our capability to run VM on Kubernetes because we have a special case which use Windows. Okay, so Kubernetes can host all the workloads in eBay, which is a magic for us. With 3 years journey of Kubernetes, we are always thinking, what is the key concept of Kubernetes? Why it is so powerful? Have you ever think about it? Our answer is declarative. Kubernetes has a straightforward, simple architecture like this, in which user can declare what they want, or we can call it a WSB, what it should be, to Kubernetes API, and a bunch of controllers watch these models and convert the WSB to the real things, such as container, VIP, volume. And the controller will also reflect the worry, what it really is, back to the model as a status. Controller is a loop, so that it always try to reconcile the WSB with the worry in case the reality has drifted with your expectation. This is the power of Kubernetes. So I'm talking about models. In Kubernetes, there's many objects, right? But what are Kubernetes modeling? Kubernetes models your application. These objects represent what its application looks like. What is your Docker image? Whether you need a volume? What's your replica you want your deployed to be? And what is the rolling update strategy? How to do load balancing, right? It's amazing that we have a Kubernetes to model your application so that engineer can transit from machine-centric to application-centric. Okay? But the question is, have you ever think about these two questions in your mind? What about the Kubernetes cluster itself? What about the fleet Kubernetes is running on? Can you use kubectl create cluster to create a cluster? Can you use kubectl get racks to get all the fleet you have in your data center? It sounds like impossible, but nothing is impossible with Kubernetes. I will share how we model our data center. If you want to build a Kubernetes cluster from scratch, where you should start from? First, you need to have some assets on some racks in availability zone and the region in your data center. And you need to connect your assets with network device such as a switch, right? After that, you need to do provisioning to install operating system to get a compute node, which can be SSH. But I'm sure that when you have thousands of machines or compute nodes, it's not a good idea to install Kubernetes by SSH. Do it manually. I don't think it's a good idea. You need a configuration management system to help you. After you get thousands of or tens of thousands of compute nodes with the configuration management layer ready, it's time for you to spin up a Kubernetes cluster, and it's really easy. In each of this step, our team extract the models, different models, and I will share in detail. First, onboard. We model our data center from region and availability zone. Region and availability zone is super easy because it's only a record for us. After this, we can query Kubernetes API to get a global view of our data center. Then it's critical for you to design your network topology by L2 domain and subnetwork. L2 domain is a representation of a top of rack switch, and subnetwork is a subnet seeder on specific switch. L2 domain can have multiple subnet on it. For example, you can have a subnet for your nodes. You can have a subnet for your pods. A rack is simple. We just want to know the location, which room, which row. Finally, you need to onboard your asset, compute asset, which represents a machine or bare metal. You want to know which the asset located in which rack, what is the SKU, what is the MAC address, and what is the switch it linked to, right? So all these things we have to model the onboard process in data center. So by these models, we can use kubectl get to get all the regions, availability zones, network zones, racks, and compute assets. I do not share any controller here because different company has different environment. The controller logic is different. But it's really a good case to understand here. If you use kubectl create a subnetwork, there should be a controller behind to configure your network device for routing or BGP. Okay? After you get your compute asset, what you want to do? You need to install operating system on your asset. You might have a different operating system for different use cases. In eBay, what do we care for an OS is the kernel version, OS version, what is the OS tree URL, OS image, depend on different OS management technology. Flavor is more complex. Flavor defines how you use your compute assets resources, such as a CPU, memory, and a disk. The most important part is the disk. You need to design how you want to partition your disk. For example, how many disks you want for BIOS boot, root disk, what is the file system you want? Do you want LVM setup or not? That is a flavor. Okay, by assigning flavor and the operating system to an asset, the controller behind need to do disk partitioning first and do operating system installation on the compute asset. Then we get a compute node. It's a SSHable compute node which can provide computing resources. As I said, if you have a large cluster, it's not a wise decision to install Kubernetes directly on thousands of nodes, right? You need a configuration management system. We use salt stack. To model a salt cluster is easy. First, you need to have a salt master on which you should install salt state tree, right? In eBay, we put our salt state tree in GitHub. So a Git repo with a revision ID can represent a salt state tree. Pillar is also important because pillar is a cluster-wide configuration. By this model, think about it. It's really easy for an operator to install new salt state tree and change pillar value just by kubeedit. Okay? Salt meaning is easy because you just need to figure out what is the salt master and is there any specific grains to be set. When you have a large-scale cluster, it's not a good practice to do configuration change in cluster-wide at a time. A little human mistake can easily destroy your cluster in seconds by a salt call, right? So we have salt deployment object here, in which I want to highlight strategy. I'm sure you are familiar with Kubernetes deployment rolling update strategy. We want to do the similar to our cluster. We want to do cluster level change. by a rolling update way. Per our experience, rack by rack is a good practice to follow because usually your application, user's application, use rack level anti-affinity for resilience. Okay, what do we have now? We have thousands of machines. We install operating system and do disk partition. Then we get thousands of compute nodes. We have the configuration management layer ready on these compute nodes. Then last step, you need to install Kubernetes cluster. You just need to define this model and use kubectl create a cluster to use one cluster, provision another. The cluster controller will do similar things like a kubeup for you, but it's more easy and simple because you only need to figure out to choose some compute nodes and label it, for example, as a Kubernetes master. Then use sort to install the etcd API server controller manager scheduler in minutes, right? It's really, really easy. Okay, we get all things done, and we have a cluster. So next is Tommy to show you how to operate by these models.
Thanks, Xiaogang, and introduce a lot of details about Kubernetes in eBay, how to design. So lots of details. Maybe you guys maybe need some time to absorb that. So right now, I will give you guys some easy time to understand how this bring the magic to the operation. So usually that recently we have like the holiday season is coming, and you guys maybe just have a good Double 11, right? Do you guys have a Double 11? Good. Okay, some things. Okay, some of us shake the head. Okay, so that is for the customer is good, but for the operation, definitely is big challenges. So one day morning that you go to the office and BU tell you, hey, Tommy, we got to build another maybe 10,000 server to handle the traffic. I say 10,000, are you kidding? When did you want that? Today. I say, okay, because right now, why I do that? Say so easy, because I had Kubernetes in eBay. So then I just run the kubectl to get computer list to see how many servers I have, because everything will be defined in the Kubernetes already. So there will be a list to show how many servers we have and the server status. Then I just go there to say, hey, Kay, I need the computer node YAML file. I already defined which application they want to be and which server I will be add and provision as the purpose. Then I define which the role, which assets, what flavor, what OS version, which port will listen. Then YAML file is ready. I just click the kube control, create. Okay, press the enter. Things going. And then I just stand up, grab some coffee, relax, chat with you guys at here. Everything's running at the back end. Then when I was come back, okay, server is ready. 10,000, maybe 20,000 already be there. So that's gonna be easy. You don't need to looking at what kind of the OS I want to provision. Did I set up the SSH ready and is the code ready? Because everything is controlled by Kubernetes. Okay, next, people will ask, okay, when you finish the server, but in case you said everything is controlled by the sort, but how's the sort master get done? The Kubernetes cluster will get out of control? I will say no, because even the sort master, the header about the Kubernetes controller is be Kubernetes controller itself. So that's kind of the magic. We mentioned that the Kubernetes can even manage itself function by Kubernetes itself. So at here you will see still I will show how many servers I get. And I'll just say, okay, this application already defined is called sort master. So sort master tell the whole application, Kubernetes itself, define them itself. Say, hey, what's the application we are, and what's the pillow secret is, and which the repo location is. And I still just go to the kube control, create this command to recreate all the sort master in the Kubernetes cluster. Then sort minion will automatically to flags the local master information be controlled. So again, even I haven't finished my previous coffee, when I go back to my seat, even the sort class master was done, I even can easy to handle that. So that's kind of the magic we have in the eBay for the Kubernetes by the Kubernetes. Okay, move on. So right now the topic is on the open source technology, even the Kubernetes version upgrade is very fast. Every 3 months, that a new version was released in the Kubernetes. So we want to have a new feature. We want to fix all the bugs in previous version. That can be challenges that we should be upgrade those kind of the whole Kubernetes cluster in very short time. So every 3 months, we should be upgrade those kind of cluster. But how many servers we have? Does anyone still remember the number? Yeah, someone raise their hand. Yeah, it's cannot be. We have 100,000 server, just bare metal. Also have 200,000 for VM. So you can imagine that if we want to upgrade that kind of the skilled side of the volume, the server, in 3 months, actually we just take 1 month to upgrade because have another 2 months, Xiaogang's team will be figure out how to get the new version to integrate. So in that case, how can we do that? 100,000 server upgrade, and everything is running on that part. You cannot let traffic goes down. You cannot just say, okay, I shut down the whole site. No way. Sounds like that you're riding like the J20, the jet flight, on the 10,000 meters high, and you change the engine, right? In the flight. So kind of be how can we change the engine in the flight? Is flying? It's kind of easy for us right now. So right now, you will see, we just define which version we want to use in the next rolling. And the secret is kind of be, we have a strategy for deployment rack by rack. That means we can do the rolling upgrade. Once we finish the testing in the dev environment, so we can gradually just take one rack out to upgrade them, and then when they finish, keep on going, move on. So because everything is gonna be defined by the module, right? So everything is in the spec is defined. So this is for the Kubernetes core component. Also we have add-ons. So tell which version we have, which the repository want to use, and how to upgrade them, which application will be installed. So everything will be defined there. So I just still collect the kube control command, create those upgrade. So whole fleet, the 100,000 server will be rolling upgrade, one rack by one rack, automatically to go in there. So we no need to human to enjoy this kind of the process, just finish that. So that's kind of how easy that we upgrade those. Okay, let's recap. So first thing, the magic of the Kubernetes to the eBay is it's simple. It's very simple. Everything can be easily defined. And we define the module and the controller is the key for the concept. So you have a module defined, you have the controller to control the module to go in to reconcile. Then you can easily to extend your Kubernetes API to fit in the requirements. Then everything goes easy. No matter how large scale the data center, easy to manage. So right now I have a few points what to highlight with you. How can we make that? Because we do everything from very beginning. From data center, we use module to define all the physical layer. Your region, your AZ, your server, your networking is be defined in Kubernetes. Then later, the configuration management layer be defined, such as I mentioned before, sort master, also sort minion, and the sort deployment used to be predefined in the Kubernetes. So you can use Kubernetes itself module to describe that. And also, Kubernetes infrastructure itself can be defined by itself. So that's kind of, you describe yourself, and you can start off by yourself. That's kind of the secret. Then based on this, we already built the whole infrastructure of the Kubernetes in eBay. Then later, no matter what kind of application, you can build a Kafka application, you can want to build the Elasticsearch application, you want to build any whatever the application based on this kind of the type, module and the controller. Once you want to release, you get it released. So everything is easy. So that's kind of be magic to the eBay. And also, that's kind of be magic to the Kubernetes. The Kubernetes itself managed by the Kubernetes. That's the magic. Okay. Here we are. Here is that's all for our today's sharing. And last, the most important is we are hiring. If you have interest in to learn this and go the adventure with us, please contact us. This is our email. Thank you. Thank you, everyone. Maybe we have a few minutes for the questions. Or we can if you guys have some private information want to share with us. Okay, we see it here. Welcome to you here. 好，欢迎大家。接下来我们还有几分钟时间，可能如果大家有兴趣，我们可以私下聊一聊，或者是有任何问题，也可以举手。OK。
你刚才说了，你们是使用那个 Cube 来去管理 Cube 对吧？那么总会需要有一个源头嘛？那能说一下关于原集群或者这方面的一些信息吗？
就是第一个 cluster 对吧？
对。
啊，这叫 bootstrap cluster， 就是鸡生蛋，蛋生鸡的问题。所以第一个 cluster 我们在3年以前就建立了，就是 KubeUp 建立起来的。不是，在3年前有 KubeUp 一个脚本。现在都变成 KubeADM 了，但之前在很久之前，几年之前吧，是 KubeUp， 就有一个 shell 脚本建起来的。所以这种方式的话，你需要有第一个 cluster 叫 Bootstrap cluster， 然后把所有的 model 注进去，然后你就用这个 cluster 去 provision。对，这有很多种做法。然后你还可以就是说 deploy 一个，比如说一个 etcd 和 Kube API server， 不是 for Kubernetes cluster， 是专门用来做这个原数据的这个存储的。对，单独的 etcd 和 API server。这是一个很高深的问题。还有问题吗？
就是我们现在用那个 Kubernetes 去管理机架和一些基础设施硬件的信息，然后我也听了eBay其他的一些分享，就感觉是说 Kubernetes 是可以作为这个数据中心的一个这个原生时代一个操作系统的这种感觉啊，就是可能说像在基础架构这个层面，岳伟同学可能就只用 kubectl 这一个命令，可能就把所有的事情都干了，所以我不知道这个真的能做到吗？就是在你们看来，你们接下来会有什么样的一个计划，或者说这个方向上会有什么样的一些挑战啊？就是这个意思。
首先第一个问题，如果他做不到，我们就不做了。所以我们认为就是你要想，在最原始的阶段，你没有自动化，你都是 manual to manage 这些 server， 对不对？或者说你的 fleet。规模大了以后，你有了自动化，你就是写了一些程序或者是 shell 脚本去做。更进一步，你有了一些 platform， 对不对？他们都能做到， 难道我通过 model and controller 的方式做不到吗？所以我一定能做到。你说 challenge 在哪里 ？challenge 是背后的那个 controller， 在 traditional 的这个 way 里面，你去做 operation， 不管是做自动化还是怎么样，它都是一个一次性的一个 routine， 对吧？它没有一个 always reconcile 的这样一个过程，对不对？有可能你一把 run 下去之后，你会发现有些 server 没有 touch 到啊，或者说 network 有一些 flapping， 对不对？但是通过 Kubernetes 这种方式，这个 controller 它是一个 loop， 它永远在对比你的 visibility， 就是你希望的东西和现实有什么差距。如果有的话，它就会去做它应该做的事情，对吗？
是的，这个，但是就是你定义这个资源，它本身它是个中态的模型嘛，所以你最开始定义的这个模型，有可能后面又衍生一些新的状态嘛。然后这个时候，假如说你又去传统的，你可能说这个要很容易去改掉它。然后在现在这个模型，你需要把它这个中态改掉，然后升级掉，然后再去操作，就会不会有一些在现实的情况下就不那么灵活，然后有一些在这个中态之外的操作？我明白他这个。
OK， 你来。
这是一个很好的问题啊，我觉得这个也是的确，我估计这位仁兄是一线，实际跟我们干一样活的。其实这样，这件事情，长话短说 ，Kubernetes 是把所有的事情包装成一个把现实生活包装成一个实际的。你可能说的是一个在生产环境上面，其实我们前面会谈到一个，我刚谈到一个，可能谈的不是太多，是 Dev environment， 因为你用 Kubernetes 包装完之后，所有 concept 底放完了之后，你的 Dev environment 其实跟你的 production 环境应该是非常相似的，所以你一旦要去 release 到之前，是在 release 到 production 之前，其实你在你的 Dev even 是 staging 环境里面，其实你可以非常容易的 reproduce 说到底会发生什么样的情况，发生什么样的，就像我们在 upgrade 我们的 cluster 的时候，我们会有同样的问题，一开始可能在我们的那个 staging environment 可能不是那么顺利，出现各种问题，后来发现 package 装不上或者有 conflict 这种，那么很早之前在前端就已经完成了。那我们很多容易的事情，但这的确是不容易的事情，会花很多精力。这也是说从 operation 的角度来讲，也会继续有人投资的这个原因。那么，但是这就并不意味但这好处在于说，当你在生产环境的时候，你非常容易，你前面可能承担的工作量会有一些多，但是到后面你会发现完全不一样。而以前是什么？你 Dev 完全测试了一遍，好像没问题了，好上生产环境又是个未知数。就解决了这个问题。对，一旦你 Dev 完测试完，你就很容易去做什么呢 ？CI/CD， 你可以不断的集成测试，然后好了之后，你去做集成这个持续的部署，非常容易。对的，对的。不知道回答你的问题没有？好，谢谢。
OK， 好，如果还有问题的话，我们就私下沟通，好吗？